bounded by y-axis, y is equal to cos x and y is equal to sin x when x lie between 0 to pi by 2. The equation of curve are y is equal to cos x and y is equal to sin x. Now we have to try to draw the rough figure of these two curves. First we draw the sine function. The highest value of this is at pi by 2 and the sine 0 at the pi, and the lowest value at 3 pi by 2, it's again 0 at 2 pi. So this is the graph of this sin x. The cos 0 is 1, so it is started from the 1, and the cos pi by 2 is 0, and the cos pi is minus 1, and cos again 3 pi by 2 is 0. So this red line is the graph of this cos function, cos x, and we have to find the green shaded area, which is bounded by y-axis, sin x and cos x, and the point of intersection of these two curves is pi by 4 and 1 upon root 2. So first we find the point of intersection of these two curves, sin x and the cos x, equating y is equal to sin x. So sin x is equal to cos x, solving we get the tan x is equal to 1, so x is equal to pi by 4. Or putting the x is equal to pi by 4 in any curve, so y is equal to cos pi by 4 is equal to 1 by root 2. So the point of intersection is pi by 4 and 1 upon root 2. So this is the actual graph of the given curves, and this shaded region is the required area we have to find out. Therefore the required area is equal to 0 to pi by 4 cos x, and the area below the sine curve we don't need, so we subtract this area from 0 to pi by 4 sin x dx. Since the limit from 0 to pi by 4 in both integrations, so we can write in the single integration from 0 to pi by 4 cos x minus sin x dx. Now after integrating we get a is equal to sin x from 0 to pi by 4 minus, and the minus is plus, so the plus cos x from 0 to pi by 4. Now putting the upper value, since sin pi by 4 is 1 upon root 2, sin 0 is 0, and plus cos pi by 4 is 1 by root 2 minus cos 0 is 1. So 1 upon root 2 plus 1 upon root 2 is 2 upon root 2 minus 1. So this can further simplify, and the final we get root 2 minus 1 square unit. So this is the required area.